This is the video presentation for the final acoustics project by Andrea Genovese and Michael Economidis. For this project, we decided to follow the predefined architectural acoustics track, which consists in developing a tool which could analyze any impulse response by calculating some useful parameters. So we decided to code a MATLAB graphical user interface, able to load an impulse response and output the parameters related to the room energy decay. So let's start by looking at the measurement part. Here we have a sine sweep function, which creates a logarithmic sine sweep. It takes as an argument the start frequency, the end frequency, the length of the desired sine sweep, and possibly you can add the silence at the end. So this function emits a logarithmic sine sweep, which spans across the desired frequencies, and also will output inverse filter of the sweep. So that will be useful later for the deconvolution of the recordings. So the sine sweep and the inverse sine sweep are saved as WAV files here. So in this case we made a 5 seconds sine sweep at 48 kilohertz. So this will be the audio file for the sine sweep, and this is the inverse. And our recordings are here stored in this folder. All these recordings were deconvoluted with the inverse filter to obtain the impulse responses, which are stored here. So once the impulse responses are stored into our folder, we can begin using our GUI. We can start with an example. We have this downloaded from the internet. This is just an example, and here you go. This is time domain reverberation decay. This is the Schroeder process. We have on this side of the GUI a bunch of parameters which have been emitted. So we have the T60. So we know T60 is not always accurate, so we also have the T30, T20, T15, early decay time. We also have the direct to reverberant ratio. We have the D50, and we also have the clarity index, the C80. We can also compute the same parameters by fitting in regression lines, which is done by clicking here. So in blue we have the EDT regression line, in green is the T30, and in red the T60. And our parameters here are updated accordingly. The same impulse response is being passed through an octave band filter bank, and we can select the center frequencies here from this pop-up menu. So we can start 125. This is the respective band decay. We have now subband parameters on this corner. So also for every subband we can also fit the regression lines, and I'm going to put one of our actual measurements, which Michael took in the large room. This is the impulse response. So this is a case where the regression curves might be more reliable for the actual decay time. It's going to be very different here. So this is it. This is our GUI. This is our tool for analyzing impulse responses. It's quite flexible and quite stable.
So apparently I'm in the dance studios on the 3rd floor, and I'm using the computer here to play back the sine sweep. The room I'm in, pretty big. I will measure the exact dimensions in a while. I'm in the middle of the room. I'm guessing this is the spot where it's gonna be most used in this room. And we're at 13 feet from the width of the room and 24 feet from the long side of the room. And we're gonna test record the first sweep. Let's see. Pretty big room. The second position, which is on the piano over there. The spot that we chose is this corner location, which is around 25 feet from the front of the room and 2 feet from the side wall over there, back there.